Hello, thank you for visiting my poster. I'm Ryan. I'm an MD PhD candidate from UCL from the McCaskill Lab, and today I would like to tell you about my project on the role of a hippocampal circuit in regulating the decision to eat. So in my work, I'm interested in decision making and how it relates to motivated behaviors. The hippocampus, shown here in red in both the rodent and human brains, is a fascinating structure that classically encodes space, but also has a role in decision making and motivated behavior. One example of a motivated behavior is feeding behavior, and we know that the hippocampus expresses receptors for circulating hormones that signal the hunger state, like the hormone ghrelin. Despite this, we still have a very poor understanding about how the hippocampus may be involved in sensing hunger and regulating feeding behavior. So, to address these questions, I studied free feeding behavior in mice. So, during feeding behavior, mice approach food and investigate it prior to making the decision to either eat the food or go on to perform some other behavior. Approach behavior therefore represents a decision point between eating and not eating, and this decision can be quantified by transition probabilities from approach to eat or not eat. Using calcium imaging, I found that the hippocampus specifically encodes approach behavior, where its activity is high during approach bouts, and activity during approach was specifically modulated by hunger. Furthermore, the hippocampus is made up of populations of non-overlapping projection-defined neurons, and it turns out it was specifically the activity of projections from the hippocampus to the nucleus accumbens, or NAC, that were sensitive to hunger. More specifically, activity of these nucleus accumbens projectors were high in the sated state and low in the hungry state. We explored the mechanisms underlying these behavioral findings by using in vitro electrophysiology to show that hunger induces changes in synaptic transmission in these nucleus accumbens projectors. And finally, we manipulated the activity of these nucleus accumbens projecting circuit using optogenetics and molecular knockdown to disrupt hunger signaling. And both these approaches showed that this hippocampal circuit has a central role in regulating the decision to eat. So overall, we describe a hippocampal circuit that integrates hunger state signals to regulate the decision to eat. So there are more interesting analysis and details of the experiments outlined in this poster, so please feel free to arrange a meeting or join the live discussion. I also encourage you to visit posters by other members of our lab for other interesting projects on hippocampal function. So thank you very much.